Hey guys, we're gonna work through the test review, so 9.1 and 9.2 test review. We're gonna talk about net change and area. Please make sure you know these 7 questions that are on here are not the only thing that's gonna be on the test. So I would go back and look at all the work that we've done so far, especially like the word problems that are setting up, what are we trying to find, and we're using an integral to find it, thinking about those kind of things. So please make sure you don't limit yourself to just these 7 problems. These 7 problems are really just practicing finding like where it's going to the right, the left, and where it's stopping. Okay, and then the bottom 4 are finding the area enclosed by the region, so we have to make sure we understand what those graphs look like. So if we're looking here at number 1, 2, and 3, it says that we have a particle moving along a horizontal line. Its position function is s of t for all t's that are greater than or equal to 0, so that means we're only looking at positive values for time. For each problem, find the velocity of the function v of t and the acceleration function a of t at time t when the particle changes, the times t when the particle changes directions, okay, and the intervals of time when the particle is moving left and moving right. Then find the displacement of the particle and the distance. So you're finding a lot of information for each one of these. Okay, so as we look at that, okay, we want to make sure that we actually know what that means, like what are we actually trying to find. So the first part here said, first we need to find the velocity function. So s of t is the position function, so the velocity function, remember, that should be the first derivative. So our velocity function, v of t, is going to be the first derivative. So remember, this is just a derivative, so this is 3t squared minus 18t. So that's our velocity. We also then need our acceleration function. So our acceleration function is the derivative of the velocity. So acceleration function is going to be the derivative of this, which is going to be 6t minus 18. Okay, so those are the 2 first functions, the first pieces that it asks us to find. Now we need to go and find the times when t when the particle is changing direction. So make sure you understand changes direction also kind of means when it's stopping. So it's got to come to a stop before it can go from right to left or left to right. So that's going to be its changing direction, that stopping point. So please remember, we are talking about the velocity when we're talking about it changing direction and moving right and left. So always make sure you have a velocity function that's given to get that information. Okay, so we're going to use that and we're going to first find where it changes direction. So how do we do that? Well, we need to find where this function crosses the x-axis. Okay, well, you can do that by plugging it into the calculator and finding that, or you can set this equal to 0 just so you guys see it by hand. If we set this equal to 0, I can factor out a 3t. Okay, so we've got a 3t and we have a t minus 6. Sorry, it's late. So then I can set each one of those equal to 0, and I'm going to get a t equals 0, and I'm going to get a t equals 6. Okay, so please make sure you know we're going from 0 to 10. So that means we're actually starting here. So this is not considered where it's changing direction, because it's where it's actually starting from. So it's not having something to change from. So when we're talking about where it changes, it's going to change direction just when t is 6. Okay, then we're going to look at where it's above and where it's below the x-axis. So if we did a little sketch of this graph, we already know we have an x-intercept at 0 and an x-intercept over here at 6, and we're really going all the way out here to 10. Okay, well, this is a quadratic function. It's going to be opening up. Okay, and these are my two x-intercepts, so I know it's going to look something like this on the positive sides, because I'm only concerned when t is greater than 0. That means that all of this down here is below the x-axis, so this is all the part that's going left. All of this that's above the x-axis, this is where it's moving to the right. Okay, so then we just need to identify that. So it's going to be moving left from 0, okay, we're including 0, until 6. Okay, we're not really going to include 6. Then it's moving to the right after it changes direction at 6, from that 6, and then please make sure you know we're not really going forever. We're only going to 10 on this one because that's where it gave us the limit. Okay, so that's where it changes, moves left, and when the particle is moving to the right. Now we have to do distance and displacement. Okay, so remember distance and displacement and what those differences mean. Okay, so the total displacement is going to account for all the positives and the negatives. So that means displacement is going to be the whole integral from 0 to 10 of my whole function. So I'm just going to write v of t dt. I'm going to let my calculator do the hard work, so I'll try to get this so you can see it a little bit better. Which way does it go to? Alright, well, not having a good opportunity to do that. So math 9 on my calculator. So from 0 to 10, I know you can't see that, sorry guys. Then I'm going to punch in the velocity function. Here my velocity function is 3t squared, or x squared in this case, minus 18x, and then dx. So on this you're going to get, you can see it, there, it's 100. Alright, so the total displacement is going to be 100. Then when we do the total distance, okay, remember this is the one where we need to make everything positive. So we're going to take this bottom piece and we're actually going to do the absolute value of that. So I'm going to have the absolute value from 0 to 6 of my function. Then I'm going to add that to the 6 to 10 because it's already going to be positive, so I don't need to worry about making it positive. If you want to, you can do the absolute value. Either way, you're still going to get the same thing. So when we type this in, we're going to get 316. Okay, so that's number 1. Number 2, we're doing the same thing. So let's look at number 2. Number 2 gives us our position function. SOT equals t to the 4th minus 9, or minus 9t cubed. This time we're looking only from 5 to 7. Okay, so 5 to 7. So the first thing we want to do is find the velocity function. So we're going to take the derivative. That's a 27t squared. Okay, remember this is the function we're going to come back to when we find all of our other information. This also asks for the acceleration function, so just remembering what this means is that it's the derivative of the velocity. So this is 12t squared, and 27 times 2 gives us a 54t. Okay, so those are our two functions. I'm going to use my calculator to find where those zeros are, so I'm typing it in to the function. So I've got 4t cubed minus 27t squared, or in my calculator it's going to be x. Going to let the calculator graph it for me. Okay, it's kind of hard for y'all to see and kind of get a picture of what that looks like. Okay, remember we're only going to be looking from 5 to 7, so I pretty much can see that only that far right x-intercept over there is going to be important to me. So when we find out what that is, remember on your calculator you can do second trace, and the option that you want is the intercept option. On my calculator, it's number 5, intercept. Nope, sorry, not intercept. We want a 0. Sorry, y'all. We want a 0, which is an x-intercept. Then you're going to want to make sure that you arrow over until you're really close to what you're looking for. So, almost there. So, I think I might have passed it. 1, 2, 3, 4, 5, 6. So, you should be able to get some dots, some lines on it. And we're going to, oh, sorry, I don't know what my problem is on this calculator. Zeros, left bound, and then right bound. Guess, so it says 6.75. So that is definitely inside here. So we know that it's going to change when t is 6.75. Okay, so just for the sake of the picture, I'm only really looking from 5 to 7, and here's 6, and it's going to change here at 6.75, and it's coming from the bottom, and it's moving up. So that's kind of what it looked like, just a little sketch. So that means all of this is where it's moving left, and all of this is where it's moving to the right. So left is going to be from the 5 to the 6.75 where it changes direction. It's going to be moving to the right from that 6.75 where it changed direction to the 7. Okay, so that's where it changes direction, where it's moving left and moving right. And then the displacement on this, remember it's just the full integral, so this one's going from 5 to 7 of our velocity function. Okay. This one is going to give me a negative 186. Yes, it's okay to have a negative as displacement, because remember, displacement is accounting for negatives as negatives and positives as positives. But distance, remember, should never be negative. This should always be positive. So we're actually doing the absolute value from 5 to 6.75 of our function, v of t dt. And then we're going to add that to the 6.75 to the 7 of our velocity function. Okay. This is going to give us 197.96. Okay. I am going to work through all of these, so I know this video might go a little bit long, but that's okay. We're just going to work through it together. And pardon me if I cough. Alright, number 3, again, we're doing the same thing. So first let's find the velocity function. So v of t is 2t minus 13. Okay, the acceleration function, a of t, is just going to be a 2. Remember, we're going back to the velocity function. That one's actually pretty easy to sketch a graph of. It's going to have a y-intercept down here at negative 13. It's going to rise to, run to. So if we set it equal to 0, we're going to get 13 halves, which is 6.5. So it's going to go something like this. And we're actually only looking from 6 to 8, so we're only going to be looking from 6 to 8. So we see it's going to be below and then above, and it's changing at that 6.5. So it's going to change, or it might say stops. Make sure you understand those are the same, where t equals 6.5. It's left from the 6 to the 6.5, and it's going to be right from the 6.5 to the 8. Okay, oh, sorry, the 8 should have a bracket on it because it's the end, it's included. Okay, then we got our displacement. So as I'm thinking about the displacement, my negative piece is going to be a lot smaller than my positive piece, so this one I'm thinking should be coming out positive. Okay, so we're going to punch that part into our calculator. It's just going to be the whole derivative from 6 to 8 of our velocity function dt. Now remember, you are actually punching in the actual velocity function in there, not just v of t. Okay, this part is going to give us a 2. Yes, positive. Looks good. Then our distance, remember, we got to do the absolute value of the negative piece, so that is the 6 to the 6.5. And then we're doing just the positive piece as it is, so the 6.5 to the 8 of our velocity function. Okay, this one is going to end up giving us 2.5. Okay. Alright. So now we're going to move down into the bottom half of the problems here. Let's see if I can make this a little bit clearer. Hopefully that helped a little bit. So we want to make sure we look at all of these pieces really carefully. Okay. V equals 2x squared plus 4x plus 4, and y equals negative 2x minus 3, and we've got x equals negative 1 and x equals 0. So these two pieces right here are kind of giving me my vertical boundaries at negative 1 and 0. Then these two are going to give me my functions that I need to find the space between. So please remember, when we're doing this, we're looking at an integral from a to b, and we're doing the top minus the bottom. Okay. If it's a function that's given to you as an x equals, remember that is when we actually do the right minus left. If you need a good example of that, and that's going to be dy, you need a good example of that. I did one of those at the end of the first day of notes on 9.2, and then I also did 2 of them on that second day of practice on 9.2. So you might want to go back and refresh that, because you definitely will see that on your test. Okay, so first thing I'm going to do, I'm going to go ahead and get these 2 functions on my calculator. Okay, again, I know you're not going to be able to see it, but I'll try to zoom, or I'll lift it up so you can see it a little bit better once I get it. So I'm going to do 2x squared plus 4x plus 4. And again, guys, I know some of you don't have calculators, and if you need to use Desmos for something like that, that is fine, but make sure that you are using Desmos just to get the graph, okay? Nothing else. You're just using that to find the graph that you need. The second function that I'm plugging in is negative 2x minus 3. So I'm going to go ahead, I'm going to graph both of these, and I'm really only concerned with when the x is negative 1 to when the x is 0. So if I look at the whole, if I look at the whole thing, I see these 2 functions. Okay, so what I'm going to do is I'm actually going to change my window, and I'm going to change my x min to the negative 1, and I'm going to change my x max to 0. I want to see just the piece that I'm actually finding the area between, because that's the part that I'm really concerned with. Okay, so maybe if you can see that a little bit better. So I got it. So the left hand side is my x equals negative 1 vertical line, and my right hand side is the x equals 0 vertical line. Okay, so I basically just put a bound of negative 1 to 0. So if you want to sketch a picture of that, you can. You don't have to. Some of them it is going to be easier to make sure you sketch a picture. So just so I have it, we're really going from here, let's call this negative 1, to here. And my top function that I used, or on here it was my blue function, it was the one that went slightly like this. Okay, and I'll call this y1, so that's this one, y1. Then my other function was actually below the x-axis down here, and it kind of went away from the x-axis. Let's call this one v, or y2. so my second function. So I can clearly see which one is the top function and which one is the bottom function. My y1 is the top, my y2 is the bottom. So we are going to take the integral from -1 to 0 because these are going to be x's, because my functions are in terms of x's, so y equals something with x's in it. And my top function that I'm going to plug in, if you're going to use the y1 and the y2 button on your calculator using vars and then the y, then that's great. If not, then what you're going to be doing is you're going to be typing this whole thing in a set of parentheses and then subtracting the second function. And that all will be with respect to dx. Okay, so again, if you're going to type it in using the y1 and y2, it really saves you actually making mistakes when you type this in because you've already got the functions in there. If not, then you are going to take your time and fill it into the calculator exactly like it is. So I would put extra set of parentheses around it. Plus 4, close that parenthesis, then subtract. I'm doing my second one, -2x minus 3, close that parentheses with respect to x, and I'm going to get that it is 4.6 repeating. So we get 4.6, we'll just round it, 4.67. Okay. Our next one here, we've got y equals 3 square root x and y equals the square root of x, and we're looking from x equals 0 and x equals 4. Those are my bounds along the x-axis. Okay, so again, all I'm going to do is go to y equals. I'm going to change my two functions here. I'm going to change the first one to be 3 square root, ooh, what did I do? 3 square root x. And the second one I'm just going to have as the square root of x. I'm going to make sure when I graph this one, I'm going to do zoom standard, just so I can go back to the original graph. Okay, so you can see this is what it looks like. The blue function is always the first one that I type in, so that's going to be my y1, and the red function here is always my y2. Okay, so we can see that they're both starting there at that 0. Alright, so if I drew myself a little picture, it would look something like this, where this one just goes up really wide, this one is like this, and we're actually going to go from this 0 to the 4. So I'm really only looking at this area in here. Okay, so since it's in terms of x, that means that we're still using the top function and the bottom function. So here the top function, this one was my y1, which was this first function that we put in. This one down here was my y2, which was the second function I put in. We're going to be going from 0 to 4 because that's where I said we want to look, from 0 to 4 on the x-axis. Right, and now we're going to just say that it's the top function, 3 square root x, minus the bottom function, which is the square root of x, with respect to x. And on this one, when we do that, we are going to plug it in and get 10.6 repeating, so I'll put 10.67. Okay. Alright, the thing that's different about the next ones is you'll notice there's no x equals 0 and x equals 4 or any of those x equals lines. That's because we're just going to be looking at the area that is enclosed by these two functions themselves. Okay, so that means we need to take a minute and graph these. So this is a quadratic function that's going to be opening up. This is a quadratic function that's going to be opening down. So we kind of should already get an idea that we're going to have something like this, and we need to find that middle piece. So, sorry. I'm going to draw my graph. I'm going to go over to my calculator. I'm going to change my functions. So I've got an x squared minus 8x plus 11, and I've got a negative x squared plus 2x plus 3. I'm going to go ahead and graph it, and as you can see. All right, so I am getting that quadratic opening up and opening down. It's not exactly like I thought, but it is my two quadratics. So I can kind of see what I'm going to have to look at here is where those two are intercepting each other. That way I know what x bound to have as my lower limit and my upper limit. Okay, that means I need to find the x value here and the x value here so I know where I'm bounding on the lower side and the upper side. Okay, so to sketch that, I'm not going to get a perfect sketch here. I'm just going to do a rough sketch. And then I've got one. Yeah, that was not a good sketch. Sorry, guys. And then my other one is going to be something like this. Okay, so we're really concerned with this point and this point so we can find the area between those two. Okay, the way that I'm going to get these x values here is I'm going to do intercept. And now I'm actually using intercept because I am finding where the two functions intercept each other. So intercept, I'm going to go on the left side. Doesn't matter if which function you start on, just as long as you pick a point on both of them. So this first one is actually at the x value of, well, I'll just write the whole ordered pair just so you guys can see. It's at 1, 4. So the x value is the 1. Then I'm going to go and do the exact same thing for the other ordered pair. I'm going to get closer to that x-intercept. And that one's going to say it's at 4, -5. So this ordered pair down here is going to be 4, -5. So the x values are the ones that I need here. Okay, so that means I need to figure out which function was this one, because that's the top, and which function is this one, that was the bottom. So in my calculator, this was y1, and this is y2. Well, this is my positive quadratic, so that means this is the one that's opening up. So this is y1. That means the one opening down, this was my y2. So when I punch this in, I'm actually going to use these x values. So from 1 to 4. And my top function here is my y2, and my bottom function here is my y1. With respect to x, I'm just saving myself writing all of that in place of that y2, and writing all of that in place of that y1. Okay, when we do that, when you type that in, we should get a nice 9. Okay, and then moving on to the last one here, number 7, we have the function y equals 2, the cube root of x squared, and the function y equals x. The function y equals x, very easy. Everybody should be able to say, here's the function y equals x. Okay, so that's going to be my y2 function. So I'm going to go to my calculator. I'm going to go ahead, and even though I already know what y equals x looks like, I'm still going to punch it in. So this is the first one is going to be 2. And then I'm going to put parentheses around this, so the cube root. So if you hit math, then you've got an option in there that has a cube root in it. You can see right there my option number 4 is a cube root. So I've got a cube root of x squared. And then my other one, just going to put x, just so I can see a good graph. Y'all can see as it graphs. The cube root function kind of looks like a funky V. And then the red one there is just my x, my y equals x. So you can see that the area that we need to find is this spot here. That's going to be between them. Okay, so that means we're going to need to find the x value at this intercept down here and the x at the intercept up here. Alright, so let me just draw this so we can kind of get a visual. Not going to be perfect, just so you can tell what we're actually finding. So we all know this point right here is 0, 0, so that's nice. My lower limit that we're going to be using is 0. Now we need to find this one up here, so I'm going to find the intercept of those two functions. So I'm just using my calculator to do that. And we are going to get, oh, this very nice point. It is at 8, 8. Okay, so we should be able to know from this bottom function was my nice y equals x. Here, that was my y2. My y1 function was my cubic, or sorry, not my cubic, my cube root function, which in this case is going to be the top of this piece, and the y equals x is going to be the bottom. So we are actually going to go from 0 to 8, and this one should be the y1 minus the y2 with respect to x. Okay, again, I'm writing these, since on the other two examples above, I actually wrote out the functions in there. I'm just doing the shortcuts on here for you. If you don't remember what buttons those are, please jump on the live session, or ask me to jump on a live session with you so I can show you how to do that on whatever calculator you have if you want that shortcut. But you don't need it. Okay? When you type that in, we are going to get 6.4. Okay? Again, please remember, these are not the only type of problems. You will see some word problems, very similar to what you've seen in our practice that we've done together. So please make sure you look over all of that stuff before your test. All right, I'll see you later.